Okay, so we continue now with more details of basics of C programming. And let's take a look next at C statements, C functions, I/O, how to do input-output, and then we'll end up with debugging and looking at the basics of using arrays. Okay, so let's look at statements. A statement can be a simple statement, that is something like x is equal to x plus 1, or x is an int, or a float, or a double, something like that. Or a statement can be a call to a function, plus maybe some other things. Or it can be even an empty statement, that's just a simple semicolon by itself. That's a simple statement, that's the simplest. It's just an empty statement doing nothing. Or a statement can be a compound statement, enclosed in open close curly braces, and so everything in there will be a bunch of simple statements or more compound statements internally. So a compound statement is one or more statements, each of which can be a simple statement or a compound statement. If you have an assignment, you have this same basic structure, that is an L value, or we think of that as a left-hand operand of an assignment operator. So for example, y is equal to x, y is the L value, and an L value is an address. So whenever you have an something assignment operator expression, what you're doing is you're saving something or storing something at the address that's indicated by this L value. So when you say y is equal to x, you're storing the value of x in the location that's indicated by y. So once again, an L value is an address, and variables are L values, constants are not L values. So you cannot have a constant and assign some value to it, because you have one chance that's when you declare a constant, you assign a value. That in that case, yeah, a constant is an L value sort of, but after that you cannot use a constant on the left hand side of an assignment operator. So once again, L value, assign operator, which can be equal. The usual assignment operator is the equal operator, but you can also have plus equals, minus equals, slash equals, times equals, and so on. And on the right hand side is some expression. Whatever this expression is, what you're interested in or what's important for the assignment is the value that this expression evaluates to. Okay, so here the standard example would be something like y equals x, but you can also have things like this. X plus equals 1 means x is equal to x plus 1. So for this, the right hand side or the expression is x plus 1, and the left hand side is x. So you're going to store the value x plus 1 into the address that's indicated by x. You can also have assignment operators on the right hand side. So for example, you can say y is equal to x plus 5. This is going to calculate x plus 5, whatever that value is, store that into x, and then the value of this whole thing, x is equal to x plus 5, that also has a value, which is the new value of x. So if x is 1, you compute 1 plus 5 is 6, store that in x, and this whole thing will have the value 6, which is also stored in y. Okay, and this works pretty much the same as in Java. Another thing that you can have is a ternary operator, which is in Java too. And this is not something that I actually encourage, but it's available in Java, C, C++, C#, Objective-C, all of those languages have the ternary operator. The basic idea is you have a Boolean expression followed by a question mark. That's saying, basically you can read it as, is this Boolean expression true or false? If it's true, then this whole thing, this whole expression, will have the value that's the same as expression 1. If this Boolean expression is false, this whole expression, that is this whole thing over here, will have the value of expression 2. So in some ways this is not exactly true, but this is, you can think of it as an if statement with return statements. So if the Boolean expression is true, then you can sort of think of this as returning this expr1, whatever it is. It can be, x plus 3 or 7 times y or whatever. If the Boolean expression is false, then you return expr2. So as in Java, this is one example of how you would use it. Let's say you have, let's say everything is an int. J is an int, I is an int, and if this int I is greater than 10, then the value of this whole expression is I minus 10. So let's say I is 11. In that case, 11 greater than 10 is true, so you return 11 minus 10, which is 1, and so you store the 1 into J. Let's say it's false. Let's say I is 9. So 9 greater than 10 is false. Therefore, what you do is you increment I. So I goes from 9 to 10. However, remember, the value of this expression is still the old value, which is 9. And so therefore, you would store 9 into the J variable. So this is something that you want to try out. You can try this out in Java. It works the same way in C++ too. So C++ or C. Okay, so next let's take a look at functions. If you're familiar with Java, you know about methods, and functions are like methods, except that the functions do not belong to a class. They're just sort of out there, and they're flat. There's only functions. There's nothing inside a function. You cannot have a function inside a function. Well, in some cases you can. But let's just say functions are flat. So the structure of C is pretty flat compared to Java and C++ and C#, in that functions are all at one level, whereas if you have something like Java or C++, you can have methods inside classes, and then you can have inner classes and so on. There's none of that in C. It's much more flat. Okay, a C function is a subprogram or part of a program that can be invoked by from some other place, usually a different function. Examples are the main function, which is the first thing that gets executed in a program. Printf, which you probably have used to print things out to the console or to a file. And then let's say something that doesn't produce any output, just maybe returns a value, like a math function like square root. So these are all examples of functions. None of these belong to a class because C does not have classes. So this is different from Java, where let's say you have the math.squareroot function, or you have system.out.printf, which belongs to print stream, things like that. So it's different. So Java has methods. C++ has classes, so it has class methods, and also it has functions like C. So C++, the whole language of C++ includes C, and so that's why C++ we say has both methods and functions. C has functions only, does not have methods. A C function can take 0 or more parameters and returns either void or some value. So for example, you can have int main. You can have the square root function, which takes as an argument a double precision number and returns another double precision number, or the math function pow for power, which takes x to the power y. X and y are both doubles, and you return a double precision number. Java methods can have input parameters just like these, and C methods and functions can have input and output parameters. That is, it's a little different. Java doesn't have output parameters. That is, when I say output parameters, what I mean is, whatever parameter that you have so these are all how Java parameters behave. But in C++, you can have parameters that can sort of return you a value back into the calling function. And C has, in some ways you can say C has the same thing. It's not quite the same, but you can think of it that way. And we'll get into more details. Okay, first let's take a look at some of the parts of a function. So you have a return value. So functions return a value of a particular type. So whatever you return has to agree in type with what's declared for that function. So in this case, it has to be a double. Has a name, and function names have to be valid C identifiers. So they can start with an underscore or a letter, but not a number. But they can have numbers after the first character. And then besides the name, you have parameters. So that can be of any previously defined type. Finally, you have one body, which is a compound statement. Each method has a body that's enclosed by open close curly braces. So very similar to Java methods, except that functions don't belong to a class. Just as an int variable can be declared without assigning it a value, you can have int x, you can have any number of variables. And similarly, a function can be declared with an empty body. So this is just saying that just like, let's say, a variable that has a variable named x, which is all you say is it has a certain type. We haven't really defined what's in that variable x. We can have a function where we don't have a method body, and it's not an abstract function or anything like that. All we're saying is that, well, we can have a function named power which returns a double. It takes two parameters that are both ints, but we're not saying exactly how it works. This is a function prototype and is used for type checking. So you can, if you're using a function from another function, you can define a function prototype and actually have the function definition somewhere else. So it's the difference between declaration of a function versus definition. So let me just scroll back. This would be a declaration of a function, and this would be a declaration with a definition. Okay, so functions can be called by other functions. So if you're in int main, you can call the square function. The square function will have to have been at least declared before main. Functions finish execution when the last statement in the function body is executed or a return statement is executed. So sometimes it can be both. That is, the return can be the very last statement, and so you exit from that function. Parameters passed into a function have to match. So the types that you pass in. So for example, whatever. Let's say we don't know. If you don't see this, you can tell that if this compiles, y has to have been an int, because square only takes ints. Okay, so parameters have to match what's that's arguments that are passed into a function has to match the parameter declaration. I guess that's how you would say it. The value returned by a function, so x times x, you don't have to second guess the type. This has to be either exactly an int or should be promotable to an int. So the way we say it is the value returned should match or should be promotable to the right hand side, which is this. So whatever you return, so first of all, x times x has to match this, has to be assignment compatible with an int, and also when you return something, the right hand side where this is the value that the function returns has to be compatible with the left hand side.